Now the sheet that you picked up only has one example on it. So I'm going to skip the top paragraph and go right to the example where it says, follow the steps below to draw the dissolving of a solute in a solvent. Use the example of water dissolving lithium fluoride. So I'm going to show the dissolving of lithium fluoride, but then maybe on the back side I'm going to show you ammonia, NH3 as well. Just to show you a separate example. Again, your backside is completely blank. And then I want to wrap up by showing you a couple different ways that dissolving can be represented besides what we did in Chem 1. Now, the reason why I picked these two substances is LiF, lithium fluoride, is an ionic compound. NH3 is a covalent compound. The mechanism for dissolving is different between the two because in an ionic compound, what we taught you in Chem 1 is that the ions separate. So maybe I'm not even completely following these steps of 1, 2, 3 in your sheet. Number 1 says draw the Lewis dot structure for each thing. Well, let's remind you, I suppose, water's Lewis dot, and we should be able to draw it bent. Remember, water is polar, so it has a partial negative end and a partial positive end. Lithium fluoride being ionic would look like this for its Lewis dot. So if my step 1 on that sheet was just, hey, a reminder of Lewis dot, there you go. Step 2 says redraw the Lewis dot structure so that the opposite charges are next to each other. With polar covalent molecules, the more electronegative atom will be the partial negative end. What I'm referring to with that is that in water, the oxygen end should be near the lithium ion because the oxygen end is the partial negative. Opposite charges attract. The hydrogen end of water should be next to the lithium. I'm sorry, the fluoride ion, because now you have the partial positive attracted to the negative. Now again, this might be the same sheet I use in Chem 1 just to introduce the topic. You guys feel free as you're doing these type of things. If you know how to draw the answer, you draw the answer, which is what number 3 is going to have us do here. So let's kind of start from scratch here. What happens in the dissolving of an ionic compound, in particular one that's small, is the ions separate. So this number 3 on your sheet is really the final answer. Ions get separated because what happens is if you have a chunk of solid, and I'll show you a picture that kind of demonstrates that in a little bit, water surrounds, attracts, and pulls it apart. It's called dissociation. Then once that happens, now the water will be all around it. Give me my dots. And remember, the water has to surround it with the correct orientation, meaning that the hydrogen end of water is the partial positive end. It should be attracted to the fluoride ion. The oxygen end is the partial negative. It should be attracted to the lithium ion. It's going to usually take more than 3 waters to surround an ion. However, typically showing at least 3 demonstrates that you understand that water has to completely surround an ion. Day 1 of this unit, we talked about different intermolecular forces. This is an ion dipole attraction. Ion because the ionic charge, dipole because polar molecules and solvents surrounding it. Seem familiar? One little twist that we could put into this is if instead of it being LiF, it could be something like Li2O. Then you'd have to have 2 lithiums floating around for every 1 oxide. Remember, the oxygen would be a -2 to represent its appropriate charge as well. So this is a 1-to-1 ratio, but some ionic compounds aren't in a 1-to-1 ratio. Now ammonia, so if you want to flip to the back side, and let's go straight to just drawing it out. Ammonia is not ionic, so it doesn't separate. Water cannot pull apart a covalent bond. So if I start by drawing ammonia, I mean, I could have drew it all 90 degrees, but I was trying to show its shape. It's what shape? Trigonal pyramidal shape. Definitely polar. Nitrogen is the partial negative. Hydrogen is the partial positive. If I surround it with water, that means then that again, opposite partial charges attract one another. This type of attraction between two different polar molecules is going to be one of the things that we talk about when we talk about distillation, although it could be a mixture of two nonpolar things as well. But water has to surround in any type of dissolving situation. Orientation is important. Orientation is referring to the fact that the partial negative of the solvent is attracted to the positive or partial positive of the solute. Again, the difference between ionic and a covalent dissolving is that the ionic will dissociate. It will break apart. This we would either call dipole-dipole attraction, or we could consider hydrogen bonding, since NH and OH bonds both have that big dipole to be called hydrogen bonding. So this would be the mixture for ammonia dissolved in water. And really, that is what we have to be aware of. We're not spending a lot of time on dissolving today. Now, I wanted to show you a couple ways that this could be demonstrated. I think I saw this example on an old AP test where students had to draw dissolving, but they used symbols instead. So here's your symbol of water. Remember, you have your two hydrogens and your oxygen. What happens if you have an ionic compound is it's a repeating unit of positive and negative charges. So a whole bunch of waters would start to surround and pull apart these parts. Even something as simple as this requires you to be able to identify which circle is for lithium and which circle is for chlorine. And that's a little bit of trends in the periodic table, because one circle is bigger than the other. Chlorine's further down on the periodic table. It's bigger than lithium that's further up. So I would expect this to be the chloride and this to be the lithium ion. So I've seen them, instead of doing Lewis dot demonstrations of dissolving, which is what I tried to show you here, I've seen them do this with balls instead, or circles. So be aware of how to do either version. There's one last thing I want to show you about dissolving. This one contains a polyatomic ion. They didn't even try to draw the Lewis dot of nitrate. I mean, they could have. They could have stuck it to you, I suppose. But this is a negative ion, just like chloride, fluoride, whatever it might be. So they have the hydrogen end of water surrounding and more attracted to the negative ion. So silver nitrate dissolved in water, they have orientation, they have the little figures to show it. Be aware of any way to represent dissolving, but these would be the most common ways, either Lewis dot form or circles to represent things. But in all instances, water surrounds, the orientation has to be correct. I think this previous one, this is something that some people would take for granted. And again, they could switch up which is the cation, which is the anion based upon size to throw people off a little bit more. But it's very common on an AP test that they have a box and you have to draw a dissolving. Okay?